In this example, we're going to take a look at the TrueShape nesting functionality in Aspire and Vcarve Pro. We're going to use this sign example that a customer wishes to cut out of a piece of 48 by 48 by 1/4 inch thick plexiglass. If we start by selecting the shapes, so click and drag to select, open the nesting form. Now the customer said they'd like to machine 2 copies of this sign, so we'll say number of copies 2 and apply. You'll see that the number 2 appears next to each of the shapes. The next thing we do is specify the diameter of the cutter that we're going to use when profile machining around each of the letters and the sign blank. So here we're going to use a 1/4 inch end mill. We're also going to specify a clearance gap. The clearance gap is important if you're going to use tabs to hold the shapes in place. For example, if we're going to profile around the letter O and around the letter L, we need to make sure that there's some material left between them for the tabs to hold on to make sure that the letters don't break free. So here we're going to specify a gap that's 0.35 of an inch. This clearance gap needs to be bigger than the diameter of the cutter. Making the gap 0.35 will leave at least 100 thousandths of material between each of the letters after cutting. We can also specify a border gap. This is a gap around the material boundary that the nested shapes won't enter. This is quite important if you're going to use clamps to hold the material on the table. If we nest these two sets of shapes into the material, so we say nest, you'll see that the software's nested the shapes into the material. If we zoom out a little bit, we've got 2 sheets. We've got sheet 1 and we've got sheet 2. This is because the software couldn't fit everything onto the one sheet of material, which seems a little bit strange because the sign blanks have got a large area in the middle that is essentially scrap material. So if we just say Ctrl Z, in the software, if we say allow parts inside other parts, switch this option on, the software is now told that it can nest the shapes inside this central boundary area to get maximum material usage. So now if we say nest, you'll see that we've just got the one sheet of material, no additional sheets, and all of the letters and the sign blank are cut out of the one sheet of material. We could improve the nest, so if we say Ctrl Z again, we can allow the shapes to be rotated by an angle to get a better material utilization, and we can also allow parts to be mirrored to get an even better fit if that's appropriate. So if we now say nest, you'll see that we get a very good fit of material usage in the middle of each of the sign blanks. So we've got additional material or space here. So if we say Ctrl Z to go back, just going to close this form for a moment. The customer's realized that he wants some additional signs making, and he sent the data to us. So he sent us an additional set of data for the words fast food. If we select this geometry, so we include this inside the original nested shapes, so we say nest, and if we just select fast food, he wants 2 of these, so we'll say apply, so 2 of that set of letters, click and drag all of the shapes. So we're going to have 2 for fast food, 2 of the Olympic Stadium, and 2 of the sign profiles or sign borders. So now if we say nest, you'll see that we've been able to get the original sign information carved or profile machined out of the 48 by 48 inch piece of material, but we've also got 2 copies of the fast food sign or the lettering for the fast food. So we're getting very good material usage, and we can cut the whole job in one go on the machine. If we close the nesting form for a moment, if we now swap from the drawing tab to the toolpath tab on the right hand side of the screen, we'll say profile machine, and say we're going to profile machine through the material, so 1/4 inch thick material. We're going to use our 1/4 inch end mill. We're going to go profile around the outside of the shapes. So now if we click and drag to select everything, we don't need to be worrying about the outside and the inside of the sign border. The software automatically knows, even though we've said outside, the software automatically knows this is the outside edge, this is also an outside edge. So now if we say calculate, software's calculated the toolpaths for us. We can preview that toolpath, and it's cut all of the shapes out. If we go back to the two-dimensional view, switch on the preview, and we can look at the preview as a dotted line. So if we zoom in, the little arrows, the line indicates the center of the cutter. If we switch on the solid preview, you'll see that that represents the channel that the 1/4 inch cutter will produce when it's cutting around each of the letters. But you'll see here that there's a gap. So there's a gap. This is the 100,000th gap that we specified, or the clearance, making sure that there's material left and each of the shapes doesn't completely break free, or the material doesn't splinter. When we're happy with the toolpath, as usual, we'd literally select the toolpath and save the toolpath, and it's then ready to run on the CNC machine. Let's go back to the design view. Let's look at another example. So file close. Open another file. This is a project that a customer wishes to engrave and cut out the shapes out of a large sheet of 48 by 48 material again. Now these are engineering drawings that we've been sent. If we try to nest these shapes, so if I select, drag and select, we say true shape nest. We're going to use our 1/4 inch end mill again. We need a gap between each of the shapes. We don't want the shapes to get within 1/2 inch of the border. If we now say we want 10 of these and apply. Now if we say nest, you'll see that the software hasn't quite got the right solution for us here. You'll see that the circles here have not, and the little crosshairs have all gone missing. The circles have been moved and it's got the nesting wrong. If we say Control Z, if we close the nesting form for a moment, what we need to do is group each of these objects together. So drag and select and say G to group. We'll do the same for the oval part on the end here, so G to group, and we'll do the same for the long bracket, so G to group. Now if we click, we select each of the objects. If we click and drag to select, and now use the nesting option, so say we want 10 of these, apply. So now it's doing the whole object in one go. So we say nest. You now see that it's nested the 10 objects and kept everything in position, which is very important. So we haven't lost any of the geometry, and the circles are all relative to their correct positions. Now if we say close, we've got all of the shapes on our sheet of material. If we click and drag to select and use the right hand mouse button, and we say ungroup back to the original object layers. Okay, that's quite important as well for machining. If we open the layer manager, you'll see here that the engineering drawing that we were working with has got a number of different layers on it. So for example, it's got the text on one layer. So text is on one layer. If we wish to engrave this text, we'd simply select the text, open the toolpath, and calculate the appropriate engraving toolpath. Very quick and easy to select the text. If we wish to drill the holes, for example, we can say switch everything off, just show me the holes. If I double click on the holes name, the holes become selected. This would then allow me to open the toolpath manager, say okay, we wish to drill the centers of these holes. Very quick and very easy, the geometry has been selected. Likewise, if we said okay, we wish to look at the outer profiles, we can select these and we can then do the necessary toolpaths. Instead of having everything switched on in one go, which makes it harder to see the wood for the trees, you'd have to go around selecting each of the objects individually. By using the layer control and ungrouping back to the original layers after nesting, this makes a big difference to the speed at which you can work when selecting objects for toolpath creation. Let's say close, or Control Z to put that back. We could also nest inside a specific shape of material. Now here we've got our 48 by 48 inch sheet of material, and but we might get down onto the workshop and realize that somebody's already cut the corner off this piece of material. So if we do, let's just very quickly sketch a material boundary. Let's say we've got a piece of material that is really this shape, so we'll say okay, it's that size and the corner's been cut off. So this is the piece of material that we've got left. If we now open the nesting form, we've got an option here to say the first vector in the selection is the boundary of the material. So if we switch this one on, so now this is very important. The first selection is the boundary for the material. Shift and select the objects that we wish to nest, and we're saying we want 10 of each. So now if we say nest, you'll see that the shapes have been fitted inside the boundary that we've specified. Control Z. It's also possible to create a boundary with a hole in it. So we might find that we have a very expensive piece of aluminum that somebody's cut the corner off, but they've also trepanned a circle out of. So they may have trepanned, for some reason they've trepanned a circle out of the middle here. So we've got a large circle. Now if we shift and select the outer boundary and the circle and group those with the letter G, they become a single entity or object. So now if we open the nesting form, click to select the material boundary, holding the shift key down, select the objects we wish to nest. Now we're not going to get 10 parts out of there, so let's see if we can nest say 7 and apply and nest. That didn't work, there was too many, so we'll say, oh sorry, we need to say, let's do that again. So the boundary material, shift and select the objects to nest. First selection is the boundary. Let's say we want 7 objects to be nested into there and nest. It's nested the shapes around the material and avoided the hole in the middle. Again, once you've nested the shapes, very, very useful to be able to select all of the objects, right hand mouse button and say ungroup to original object layers. We do that and you'll see now if we select, for example, we select a hole, so click on a little red hole. Down in the bottom right hand corner it indicates the layer name as being the holes. So just to summarize, the true shape nesting, it's very important to specify the tool that you're going to use. Sometimes you will also need an additional clearance gap, and then you've got options for nesting, being able to rotate the shapes, being able to put shapes inside holes or areas where there's scrap material available to use. And you can also nest from the bottom left hand corner, from any of the corners, and force the nesting sequence to be along an axis, so along the x-axis or along the y-axis. If you're using an arbitrary shape for the nesting boundary, then this needs to be the first vector that's selected, and you can also specify multiple copies of the selected shapes. Hope you found this tutorial interesting. Thank you.